Section 3.5, Dividing Polynomials. Before we start performing division with polynomials, let's recap how we perform division with numbers. We'll start off with 3,157 divided by 6. The setup for long division is the number we're dividing by goes outside of the division symbol, and the number that's being divided goes inside of the division. Now, we'll take a look at 3. Can we do 3 divided by 6? No, 3 is too small. So we'll take a look at the next digit along with 3, which forms 31. What times 6 gives us something that's less than 31 but very close to 31? That'd be 5. And we know 6 times 5 is 30. Now we'll subtract to get the remainder, and we get that 31 minus 30 is 1. Now we bring down the next digit, and we repeat the process over again. How many times does 6 go into 15? That'd be 2 times. 6 times 2 is 12, and 15 minus 12 is 3. Bring down the 7, and we do this again. How many times does 6 fit into 37? That'd be 6 times. 6 times 6 is 36, and 37 minus 36 is 1. Now there's no more digits left to bring down, so the 1 at the end we refer to as the remainder. So 3,157 divided by 6 equals 526 with a remainder of 1. Now we'll define polynomial division. We're going to let p of x and d of x be polynomials. To denote polynomial division, we'll either write p of x divided by d of x like we would with numbers, or we would write p of x over d of x looking like a fraction. But polynomial division is the process of obtaining two polynomials, q of x and r of x, where r of x has a degree less than d of x, such that p of x divided by d of x equals q of x plus r of x over d of x. P of x, the polynomial that's being divided, is called the dividend. D of x, the polynomial that's doing the dividing, is called the divisor. Q of x is referred to as the quotient. R of x is referred to as the remainder. Just like with numbers, if our remainder r of x equals 0, then we can say d of x divides p of x, or d of x is a factor of p of x. We are going to see in a future section where we're really going to want remainders to be 0 to help us factor. Now we're going to take a look at how to perform polynomial division. We're going to look at two ways of performing it. One that is the most general way, and the other way is a shorthand that can be used under very specific circumstances. The most general way to perform polynomial division is through what we call long division. The process of long division with polynomials is very similar to long division with numbers that we saw in the first example. The first step in performing polynomial long division is first set up the division problem. We'll take a look at 2x cubed minus 4x squared plus 5x minus 10 all over 2x squared plus 5. Just like with numbers, what's doing the dividing goes outside of the division symbol. When we write our polynomials, we do want to make sure each power is accounted for. So the 2x squared plus 5, which we're putting outside of the division symbol, notice how it is missing the x term. To make sure everything is aligned properly, we'll place a 0x as a placeholder. Now the numerator, the polynomial that's being divided, will go inside of our division symbol. And if you look, we have an x cubed, x squared, x, and a constant term. All the powers are accounted for, so we'll write it in without any modification. Next, we're going to go to the dividing step, where we divide the leading term of our p of x by our leading term of d of x. This quotient we're going to put above the division symbol. 2x cubed divided by 2x squared would be x. In order to keep my work organized, since x is a first degree term, I'm going to put it above the first degree term of our p of x. Now that we've completed step 2, the dividing step, we'll move to the multiplying step. We'll take our result from step 2, the x, and we'll multiply that with our polynomial that's doing the dividing, the 2x squared plus 0x plus 5. And we get 2x cubed plus 0x squared plus 5x, which I'm going to write underneath my dividend, and I'm going to write it so all the corresponding powers are aligned. Now we'll move to step 4, which is subtracting. We're going to take our result from step 3, and we're going to subtract that from our p of x. 2x cubed minus 2x cubed, they're going to cancel. We should always have those leading terms cancel if we divide it properly. Negative 4x squared minus 0x squared is negative 4x squared. 5x minus 5x, they do cancel, but because I want to make sure everything stays aligned properly, and because the x term would not be my leading term, I am going to keep it as plus 0x. Now we go to step 5. Since we finished subtracting, we can bring down as many terms as we need from our dividend. Ideally, we want as many terms as there are terms in our divisor. If you need to, you can bring down more than one term if you need to. And now we'll proceed to repeat this process. We'll divide negative 4x squared by 2x squared. We get negative 2. Multiply the negative 2 with the 2x squared plus 0x plus 5. Then we subtract. Negative 4x squared minus negative 4x squared is 0x squared, so they cancel. 0x minus 0x, we can cancel them out since that would be a 0 leading term, which we'll never write down. Then for negative 10 minus negative 10, they also cancel, so our difference is 0. So here, there's no more terms to bring down, and we got a remainder of 0. So 2x cubed minus 4x squared plus 5x minus 10 all over 2x squared plus 5 is equal to x minus 2. Based off of what we defined in the last slide, because our remainder was 0, that tells us that 2x squared plus 5 is a factor of 2x cubed minus 4x squared plus 5x minus 10. Now we'll do 2x to the fourth plus 2x squared plus x minus 10 divided by x squared plus 5. X squared plus 5 is our divisor. That'll go outside of the division symbol, but notice how it's missing an x term, so we'll write it as x squared plus 0x plus 5. As for the 2x to the fourth plus 2x squared plus x minus 10, our dividend, that is missing an x cubed term. So we'll place a 0x cubed term in its place, and now we have our division set up. Now we'll go to step 2 and divide. 2x to the fourth divided by x squared is 2x squared. Now we multiply. 2x squared times x squared plus 0x plus 5, and we get 2x to the fourth plus 0x cubed plus 10x squared. Now we subtract. 2x to the fourth minus 2x to the fourth, they're going to cancel. 0x cubed minus 0x cubed, they're also going to cancel, and we'll cancel them out since that would result in a leading term of 0x cubed, which we don't want to write. And then 2x squared minus 10x squared is negative 8x squared. Now we'll bring down the x, but we only have 2 terms while the divisor has 3, so we'll also go ahead and bring down the negative 10. Now we'll repeat the process. Negative 8x squared divided by x squared is negative 8. Multiply negative 8 with x squared plus 0x plus 5. Now we subtract. The negative 8x squareds cancel. X minus 0x would be x. Negative 10 minus negative 40, positive 30. There are no more terms to bring down. And notice how the degree of the x plus 3 is smaller than the degree of the x squared plus 0x plus 5, which we're dividing by. That tells us we are done our polynomial division, and the x plus 30 is our remainder. The way we'll put our remainder in place is we'll put plus our remainder x plus 30 over what we divided by, which is the x squared plus 5, and we no longer need the 0x. We only put that there as a placeholder for the division. So our answer through this polynomial division is 2x squared minus 8 plus x plus 30 over x squared plus 5. Since we had a remainder that is not 0, then x squared plus 5 is not a factor of the 2x to the fourth plus 2x squared plus x minus 10. Now we'll do negative 6x cubed plus x squared minus 4 divided by 2x minus 3. 2x minus 3 will go outside the division symbol, and there are no missing powers. The negative 6x cubed plus x squared minus 4 will go inside the division symbol, but we are missing an x term. So when we write that inside of our division symbol, we'll put a plus 0x. Now we can start dividing. Negative 6x cubed divided by 2x will be negative 3x squared. And when we multiply, we get negative 6x cubed plus 9x squared. Now we subtract. The negative 6x cubes cancel. X squared minus 9x squared is negative 8x squared. Now we can bring down the next term. Here, since I'm dividing by a two-term polynomial, I only need two terms for the division. If you want to bring down the negative 4 as well, you can. But now we'll divide. Negative 8x squared divided by 2x is negative 4x. Multiply. And we get negative 8x squared plus 12x. Subtract. 8x squareds cancel. 0x minus 12x is negative 12x. Then we'll bring down the negative 4 and repeat one more time. Negative 12x divided by 2x is negative 6. Multiply. You get negative 12x plus 18. Subtract. Negative 12x is cancel. Negative 4 minus 18 is negative 22. So since negative 22 is our remainder, we'll put minus 22 over 2x minus 3. So our answer to the polynomial division is negative 3x squared minus 4x minus 6 minus 22 over 2x minus 3. Negative 3x squared minus 4x minus 6 is the quotient. Negative 22 is the remainder. Because negative 22 is not 0, then 2x minus 3 is not a factor of negative 6x cubed plus x squared minus 4. Now we're going to talk about shorthand for long division that we can only use in specific circumstances. This shorthand is referred to as synthetic division. Synthetic division is a shortcut that we use anytime we're dividing by d of x equals x minus c. C can either be positive or negative, so all the minus c indicates is just how we're going to interpret c when we set up our division. So do keep that in mind. You may see x plus a positive number. That minus c just tells us how we have to treat the value of c based off the signs we see. What's great about synthetic division is it only uses the coefficients in the process. And this is going to reduce a lot of the writing and a lot of the work that we need to do through this process. If we take a look at our first problem in example 3, we're going to divide x to the fourth minus x squared minus 120 by x minus 2. Since we're dividing by x minus 2, we can use synthetic division, and our c would be positive 2. Our c is going to be the opposite sign of what we see in our divisor. To set up our synthetic division, we're going to put a little box with the 2 to represent our divisor. Then we're going to start listing the coefficients of our dividend. Any power that's missing, we're going to represent with a 0. So we have 1 x to the fourth, 0 x cubed, since the x cubed term is missing, negative 1 x squared, 0 x because the x term is missing, and then negative 12 for the constant. And then we're going to put an underline with a little bit of space. Now to perform the division, step 3, we bring down the leading coefficient, which here is 1. Then step 4, we're going to multiply the leading coefficient by c. So we're going to multiply 1 and 2 together, and we're going to put that right underneath the 0 above the line. Now we're going to go to step 5, where we're going to add the two terms in the second column. So 0 plus 2 is 2. Now we're going to go to step 6, which is to multiply our result by c. So 2 times 2 is 4, and we're going to place the 4 in our third column. And we're going to keep repeating steps 5 and 6 over and over again. We're going to add the entries in the column. Negative 1 plus 4 is 3. Multiply by our c. 3 times 2 is 6, which we're going to place in the fourth column. Add again. 0 plus 6 is 6. Multiply. 2 times 6 is 12. Add. Negative 12 plus 12 is 0. Since that was the last column, we are done. What we get underneath the line are the coefficients to our quotient and what our remainder will be. The entry in our last column would represent our remainder. And then as we go from right to left, we're going to get the constant, the x, x squared, x cubed, and so on and so forth. So 6 is the constant term, 3 is our x term, 2 is our x squared term, and 1 is our x cubed term. It's always easier to read your answer from synthetic division from right to left, because the farthest right is always the remainder. The farthest left would represent the coefficient that is one less degree than the degree of your dividend. So from our synthetic division, our answer would be 1x cubed plus 2x squared plus 3x plus 6. And since the remainder is 0, there is no need to write 0 over x minus 2. And you can notice with the synthetic division, a lot less writing. And once when you get more comfortable with the process of the repetitive adding and multiplying, it is significantly faster. Do keep in mind, though, synthetic division only works in a very specific circumstance, where we're dividing by polynomials in the form of x minus c. Now we're going to divide x cubed plus 4x plus 2 by x plus 5. Now, at first glance, it may seem that we can't use synthetic division. I said before, synthetic division can only be used when we divide by polynomials in the form of x minus c. But if you look at x plus 5, we can rewrite it as x minus negative 5. So here, x plus 5 is an appropriate divisor for synthetic division. It's just that our c is negative 5. So when we set up our synthetic division, negative 5 will go in the little box. Now we'll list the coefficients of our dividend. 1 for the x cubed. Since we're missing the x squared, we'll put a 0. Then 4 for the x term, and then 2 for the constant. Now we'll bring down the 1, multiply, negative 5 times 1 is negative 5, add 0 plus negative 5 is negative 5, multiply, negative 5 times negative 5 is positive 25, add 4 plus 25 is 29, multiply, 29 times negative 5 is negative 145, add 2 plus negative 145 is negative 143. Reading from right to left, negative 143 is our remainder, 29 is our constant, negative 5 is our x term, 1 is our x squared term. So our answer is x squared minus 5x plus 29 minus 143 over x plus 5.